Sir,
Okay, so so we'll continue with the whatever things we have seen yesterday. So these are the topics which we are going to cover. Some of the topics we have already covered. So we'll move on faster. So digital circuits. Yesterday also we discussed that there are two types of digital circuit. One is combinational circuit and sequential circuit. Combinational circuit, we discussed that the output at any instance of time depends on the input present at that instance of time. Means the output depends on the current input. And in sequential circuit, the output at any instance of time depends on the present input as well as past input or output. Means whatever inputs are present right now and whatever input or output was there at previous event or time, the output depends on that. Okay, so and since we need to know the past input or output in sequential circuit, we need to store this past input or output. If you don't store, what will happen? That will be lapsed and you will not be able to get it. So you need to store the past information, and for that purpose you need a memory element known as you need a storing element known as memory. Normally flip-flops are used for this purpose. Okay, flip-flops are used for such purpose. So this is the this is sequential and combinational circuit. Okay, one more thing is this sequential circuit comprises of, sometimes it comprises of a combinational circuit also. Means if you want to design a sequential circuit, it may have a sub circuit as combinational circuit. Then these are the four ways for simplification, that is algebraic method, Karnoff map technique, Wien-McCluskey method, and VEM technique. Out of these first two we are going to study, remaining two we are not going to study. K-map technique is used to simplify up to 6 variables. Okay, now what do you mean by variables? That we'll see later in upcoming slide. But from programming point of view, K-map method is a bit difficult to program. It's not feasible that much. So from programming point of view, Wien-McCluskey method is used. Okay, so whenever you want to program any circuit, you have to use Wien-McCluskey. If you want to go for simplification of Boolean function, you cannot go for K-map. So minterms and maxterms yesterday also we discussed. So in sum of product we have minterms, and in product of sum we have maxterms. So what is minterms? So minterms are basically represented like, okay, now this A, B, C becomes a variable. Okay, this A, B, C, whatever we said here, okay, K-map can simplify up to 6 variables. Means it can take up to 6 variables like this, A, B, and C. Right now we have 3 variables, but it can simplify up to 6 variables. Now why it is said as variables? As all of you are aware about programming language, you are aware about variable and constant. Constant are those things which doesn't change their value, and variables are those things which changes their value. So here ABC also changes their values. That's why these are called as variables. So these are variable names. Okay, A, B, and C are the variables. It can have values like this. Different 8 combinations we can have. Why 8? Because 3 variables are there. So 2 raised to power 3 becomes equal to 8. So that's why we can have 8 different combinations, like 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. In the similar, okay, now how to write down the minterms from this? So whenever there is a 0, you have to represent it with complemented form, that is bar, and whenever there is a 1, you have to represent it with uncomplemented form. So here minterms can be written as A bar since A is equals to 0, B bar since B is equals to 0, and C bar since C is equals to 0. So that's why minterm for this combination can be written like A bar, B bar, C bar. In the same fashion, we can write down the minterm for this combination. So A is equals to 0, that's why A bar, B is equals to 0, that's why B bar, and C is equals to 1, so C. In the same fashion, you can write down remaining things. Now product of sum. So max terms. Now max terms. So whenever 0 is there, it is represented in the uncomplemented form, and whenever 1 is there, it is represented in complemented form. So since a is equals to 0, that's why we are writing down only a plus product of sum. So you have to take the sum. Okay. So a is equals to 0. So a plus b plus c. A plus b plus c bar. Since c is equals to 1, it is represented as c bar. In the similar fashion, you can write down remaining terms. Yesterday we seen this, so I'm not spending much time on this. All of you got this? This is required because for further means examples, we need this. All of you got this? Please reply.
Yes, sir.
Okay.
Yes, sir.
Now, so algebraic procedure to obtain canonical SOP. SOP means sum of product. What is this procedure? So what you have to do is you have to examine each term of a given SOP expression. If it is not a min term, go to step 2. Not a min term means what? If it is not in all variables, okay, then you have to say that this is not a min term. Right now we are having all the 3 variables, so we are saying that it is a min term. But sometimes it may happen that here a b bar, so c is not there, means it is not a min term. Here a and b are not there, means it is not a min term. Here a b c, all 3 things are there, means it is a min term, right? So if it is not a min term, you have to go to the step 2. For all missing variable x, for example here c is missing, so you have to multiply the term by c bar plus c. Here a and c both are missing, so we have to multiply it with a bar plus a, c bar plus c. Okay, here this is a min term, so no need to multiply anything, and you have to observe all the product and eliminate redundant product terms. So this we have done in yesterday's class also. This is another example which I would like to take. So that example is taken like this: ab bar plus b plus abc. Look, ab bar plus b plus abc. So that is mentioned. The final answer is this. Just for reference, I have written this. Now let us solve this. So what to do now? What to do now? Can anyone tell? Please help me out. Equal to. Can anyone tell? Please reply.
A B sir, A B C
A
C
plus
bar plus C.
A
B bar
dot B bar
into C bar plus C.
into C bar
C bar
plus
plus
C.
C.
Then
Plus B into
plus
B.
A bar plus A.
A bar plus A and C bar C.
into
C.
A bar plus A into C bar
C
plus
plus C.
C.
C. Next plus what?
A
A,
into B into C.
B and C, right? No need to multiply anything. Okay, one more thing I would like to tell you. This is mentioned at f of a, b, c, means this is a function of 3 variables a, b and c. Got it? So this thing also you have to keep in mind, or you have to observe. If it is mentioned as f of a, b, c, comma d, it means that this is missing c as well as d. This is missing a, b, c, sorry, a, c, and d, and this is missing d.
D.
Then in that case, you have to multiply d bar plus d,
D. Yes, sir.
right?
Yes.
Since in this function f of a, b, c is mentioned, means it has only 3 variables.
Yes, sir.
That's why we are using this. Now, if we simplify this, what we'll get? A plus, sorry, a dot b bar dot c bar plus, you have to simplify it, okay? So a b bar dot c plus what? A bar b c bar c bar plus a bar
bar
a bar b plus, sorry, not plus, a bar b c, right? A bar b c bar plus a bar b c plus what else? A b c bar a
B
b c bar plus
bar
a
B C
plus what is remaining? A, B, and C. Got it? A bar, B, C bar, A bar, B, C, A, B, C bar, A, B, C. Right? So we have simplified it. Now what we have to do? We have to take the common things. So A, B bar, C bar. I'm writing down this. A, B bar, C bar. Now what I have to do? I have to see which one, if this is there or not. A, B, C bar, A, B bar, 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 C bar. So A, B bar, C bar is not there, right? So now next plus, I will take this A, B bar, C, A, B bar, C plus.
A bar B.
Once again, I will check.
C bar.
Okay. Once again, I will check whether this is there or not. So A, B bar, C.
No.
A, B bar, C.
No,
A, B
it is
bar,
single.
it's not
Single
there.
EO.
Right. So again, what we can do? We can take this A bar,
A bar B
A bar
C bar.
C bar.
B, C bar. Let's check
C
out
bar.
whether they. Let's check out whether it is there or not. So A bar, B, C bar, A bar, B, C. It is single, right? So no need to do. Then A bar, B, C, A bar, B,
B C.
C is single.
C.
So then next is
A B C bar.
B,
A B C bar. C bar.
C bar, and we can take only single time this ABC.
A B C.
AB. So if you observe, this is the canonical SOP of given expression. So AB bar, C bar, AB bar, C bar, it's there. AB bar, C, AB bar, C, A bar, BC bar, A bar, BC bar, and then AB bar, BC, A bar, BC, ABC bar, ABC bar, ABC, ABC. Means this whatever we got is correct. All of you got this? How to find out the canonical SOP if it is asked in exam? Any doubt?
No, sir.
Sir.
Okay.
No, sir.
Similarly, you can go for obtaining canonical POS form, that is product of sum form. So you have to examine each term of a given POS expression. If it is not max term, you have to go to step 2. So what you have to do over here, for all missing variable x, you have to add the term by x bar plus dot x and obtain all the sum terms and eliminate redundant terms. So let's take this example. F is equals to ABC. Okay, means it has only 3 variables, a, b and c, and is equals to a plus b into a plus c into b plus c bar. So if you observe, in this expression, in this term c is missing, in this term b is missing, and in this term a is missing. So what we can do, we can do like this: a plus b, a plus c, b plus c bar. So in first, c is missing, so we can add c bar dot c. In second, B is missing, so we can add B bar dot B. In third, A is missing, so we can add A bar dot A. Okay, then you have to split it. So how to split? A plus B plus C and A plus B plus C bar. This also can be splitted: A plus C plus B, A plus C plus B bar. This also can be splitted: B plus C bar plus A bar, B plus C bar plus A bar. Got it? Then you have to find out the redundant term. So here A plus B plus C and A plus B plus C is here. So you can neglect this. Then A plus B plus C bar, A plus B plus C bar is also there. So neglect this. Then A plus C plus B bar is not there. And so this only four terms will be left: A plus B plus C, A plus B plus C bar, A plus B bar plus C, and A bar plus B plus C. Got it? All of you
Yes,
got
sir.
this
Yes, sir.
or not?
Yes,
Fine. So
sir.
what simple conclusion we can draw is that if brackets are there, then you have to add the term with C, means with like this. Okay, you have to add. And if bracket is not there, then you have to multiply. So you have to put the bracket. This is the identification you can have for solving this. Don't get confused. Here we don't have any brackets, so you can add such type. You can add such type of brackets or parentheses. And here you don't have. You have already parentheses, so you have to just add the product. Okay. Now, yeah, let's take this one of the example: A bar, B bar plus C bar. Sorry, C. So this is in POS form, that is product of sum. Sum is there, and then you have taken the product. Okay, like this. So now we need to find its canonical POS form. So how to do? This is one term and this is another term. So in this term, which one is missing? What is missing?
B bar plus
B
B,
and
C
C
bar
is
plus
missing,
C.
right?
Yes,
B
sir.
and C is missing. So what we can do?
Yes.
We
Yes,
can
sir.
write like this: A bar,
A bar,
B bar plus B.
A bar. So we have to add, right? We have to add.
plus.
So what we can add? B bar
Yes, sir.
dot
Plus B bar
plus
plus C bar
R plus C.
plus C bar
C.
plus
B.
C bar C. Is it correct or not?
Plus
yes, sir.
yes, sir.
To A
So
bar
this first term is complete.
It's correct.
into A
Now
plus
we have to take this.
yes,
So
sir.
what to do?
A bar
A bar
into A
B bar
plus B bar plus C.
dot
A bar into A
plus B bar.
B bar
B bar
plus
plus C.
plus C.
Correct?
Yes, sir.
Yes, sir.
Now you have to split this. How to split this? A bar plus
Plus B B.
B bar, B bar,
B.
Anything you can take, any of this. So let us say pepper. Okay, I am taking B plus I am taking C.
Plus C.
C,
Okay, so this is 1. Then A bar plus B plus C bar.
Bar.
plus C bar,
Next I am taking A bar plus B bar
B
plus
bar plus
Bar
C,
plus C.
C. Next I am taking A bar
A
A plus
plus B bar plus C
C.
bar.
Bar.
Is it correct?
ये नहीं सर,
Yes, sir.
नो सर,
Huh?
सर वो वहाँ पर A बार आया ना सर, A बार
B
B
बार
बार प्लस A बार प्लस C बार,
होता है.
Okay, what I am
ये
doing?
होगा ना सर वो,
What I am doing? A bar plus B bar plus C.
Plus
A bar plus B plus C. This one I have taken. Next time A bar plus B plus C bar. This I have taken. Next time A bar plus B bar plus C. This I have taken. A bar B bar C bar. This I have taken. Got it?
yes sir,
Any
yes, sir.
doubt in this?
Sir, can you
Huh?
repeat again this term?
Okay, what we have done now
Sir,
here,
A bar plus B bar.
A bar plus B plus C. Okay, this one combination. Second combination is A bar B plus C bar. This is another combination. Third combination is A bar B bar, sorry, A bar B bar C. And fourth combination is A bar B bar C bar. Like these 4 combinations I have. Got it?
yes sir,
Now similarly I can split this also. So what I will get? A bar or A plus B bar plus C. This is one, and second one is A
A bar
bar plus
bar plus
B bar,
B bar plus C,
B bar plus
C,
C. Now what I have to do? I have to find out which is redundant term or common term. So A bar B plus C is there. A bar B plus C, A bar B plus C, A bar B plus C, A bar B plus C. It's not right. So this is the unique term. Then A bar plus B plus C bar. A bar plus B plus C bar. A bar plus B plus C bar. It's also unique. Then A bar plus B bar plus C. A bar plus B bar plus C. A bar plus B bar plus C. So this is redundant. So I can remove this. Correct? Yes or no?
yes sir,
Yes.
Then A bar plus B bar plus C bar. A bar plus B. So remaining are these. So now this I can write down over here. So if you just will cross verify. A bar plus B plus C bar. A bar plus B plus C. C. So this is true, right? Then A bar plus
yes,
B plus C bar. A bar plus B plus C bar. This is true. A bar plus B bar plus
yes,
A bar plus B bar plus C. So this is true. A bar plus B bar plus C bar. A bar plus B bar plus C bar. This is true. A plus B bar
yes,
plus A
A
plus
bar,
B bar plus. So means whatever we got is correct.
yes sir,
Got it, all of you?
yes sir,
Okay. So
Yes, sir.
so like this you can obtain the canonical SOP and canonical POS form. So what I expect you that all of you will take the previous question paper from MSBT and will solve such type of problems which have occurred in the exam. Can you do that?
yes,
Hmm?
Yes, sir.
On
yes, yes sir,
on mobile there is an app known as MSBT
Yes.
exam. I think all of you are aware about that. The app name is MSBT. Wait, I'll tell you the name of the app. exam papers for MSBT. There is an app on that, like this. I think, is it visible?
Yes, sir.
Yes, sir.
Is this app visible?
Yes, sir.
Yes, sir.
Okay. So such type of app is there on which you can get the question papers. Okay. So just have a look on that and see question papers available, and you can.
App not visible.
App is visible or not? This app is there. Exam papers, MSBT.
No, sir.
Okay. So if you click, you will get such type of thing. Here you will get everything related to MSBT. So you can have the previous question paper also. So just go through it and see what sort of questions has asked on this topic, and you try to attempt it by your own. Okay. Is it fine?
Yes, sir.
Yes, sir.
Okay. And again we'll go to the PPT. Next is transforming one form to another. Means if I have a SOP, how to convert it into POS, and if I have a POS, how to convert it into SOP. That is the question. So the basic conversion is SOP to POS and vice versa. So how to do that? That is the question. So suppose such type of equation is given: f of ABC is equals to a bar plus a bar dot b bar dot c bar plus a bar dot b bar dot c plus a bar dot b dot c bar, and so on. If such type of equation is given, this is in which form? SOP or POS? Can anyone tell me? This function is in SOP or POS form? Which form it is?
SOP form.
SOP.
SOP.
Right? Because product is there
Product,
and
yes, sir.
sum is there.
SOP.
Yes, sir.
So this is SOP form. Now we need to convert this into product of sum form, POS form. So how to do it? What you have to do, you have to take the double, means De Morgan's theorem. Okay, you have to double complement it, and you have to apply the De Morgan's theorem. So I have applied, okay, this function is there. So I have applied single complement and double complement. So as soon as I apply single complement means this term occurs because its product is 1. So complement of that means 0. So what now we have taken 5, means in this question 5 terms are there: 1, 2, 3, 4, 5. So remaining 3 terms are nothing but the complement of this function. Okay, so that's why a bar bc, which is not there in this, is a complement of this function, plus ab c bar and ab bar c. These are the complement of given function, one's complement. Okay, got it? All of you got this?
Yes, sir.
Okay, because ABC can have 8
Yes,
different
sir.
combinations. ABC can have 8 different combinations like this. Correct? We can have 8 different combinations like this. And its minterms are this. Okay? So if I am considering 5 of this, okay, 5 of this, then the remaining 3 terms will be the complement of other 5. So in this expression, whatever terms are not mentioned, those will be the complement of this equation. So a bar bc plus ab c bar plus a b bar c are not the part of this equation. It means these are the complement of this equation. That's why f bar is nothing but A bar BC plus AB C bar plus AB bar C. Now only single complement is remaining. Got this point? All of you got it or not?
Sir, please repeat again.
Okay. What happens? We have three variables. So three variables can have 8 combinations like A, B, C. A, B bar, B, C bar, A, B bar, C, A, B bar, C bar, then A bar, BC, next is A bar, B, C bar, next is A bar, B bar, C, and last one is A bar, B bar, and C bar. Correct? Can we have this much combinations with ABC? Yes or no?
Yes, sir.
So we can have these 8 combinations with the help of ABC. Now, if I want to find out complement of this function, okay, once complement of this function, then I need to first find which min terms are already covered. So A bar, B bar, C bar is already covered. So okay, sorry, this I missed it. So this should be A bar, B bar, C bar, right? So this combination is already covered. A bar, B bar, C bar. A bar, B bar, C is already covered. So this is also covered. A bar, B, C bar is already covered. So this is also covered. A, B, C bar is covered. So A, B, C bar is already covered. A, B, C is also covered. So this is also covered. Now the remaining 3 terms, okay? A, B bar, C, A, B bar, C bar, and A bar, B, C. These are the complement of these terms. Got it? Yes or no?
Yes, sir.
Whatever terms are mentioned, if I want to find out the complement of that, then the remaining terms becomes the complement of this. So that's what I have said. I have mentioned f dash f complement is nothing but these 3 combinations. So that's why I have mentioned A B bar C, A B bar C plus A B bar C bar. Something is missing. Oh, okay, wait. Is some here? Its correction is okay. A B bar C bar, and third one is A bar B C, A bar B C. Got it? So this 3 becomes the f complement. Now we have to, okay, this complement is for C, not for whole. Now we need to take the complement of this, whatever we found, and the in order to take the complement of this, we have seen De Morgan's theorem, and De Morgan's theorem is nothing but A plus B whole bar is equals to A bar dot B bar A bar dot B bar, right? This is one De Morgan theorem, and another De Morgan theorem we have seen is A dot B whole bar is equal to A bar dot B bar. Sorry, A bar plus B bar. Correct? Do you remember this De Morgan's theorem?
Yes.
Yes, sir.
So we are using this De Morgan's theorem. So what we can do, now this bar is nothing but this bar, right? So what I am doing, this plus is there, means this is in form. So what I'm doing, I'm converting this into this. So a bar plus a bar dot b dot c whole bar into a dot b dot c bar whole bar plus sorry dot into a dot b bar dot c bar whole bar, and I'm applying another theorem, this theorem, on that terminology. So what I will get, a plus b bar plus c bar. Okay, if I convert this, if I want to, if I convert this, okay, what I will, if I apply this De Morgan's theorem, this one, okay, if I apply this De Morgan's theorem to this equation, what I will get, a bar bc whole bar into a b c bar whole bar into a b bar c bar whole bar. Correct? All of you got this? This complement is there, means this bar is there over here. If I want to convert this, I will get this. Is it correct? Getting or not? Yes or no?
Yes, sir.
Please reply. Now what I'm doing, I'm applying De Morgan's theorem on this individual term. So I'm applying De Morgan's theorem to this individual term using this theorem, second one. So what is there? If bar is not there, bar you have to mention. Okay, so here bar is not there, so bar you have to mention, and dot will be converted to plus. So a bar, since bar is already there, it will be again complemented. So this becomes a plus b bar will come plus c bar will come. Okay. Similarly for this, a bar plus b bar plus c, a bar plus b plus c. Okay, not bar over here. Bar is not there. Okay, this is mistake. It's not there. Okay. So a bar plus b plus c. Got it? Yes or no?
Yes, sir. Yes, sir.
Now, if you observe, this is the product. This is in which form? Product of sum. This is in which form? Product of sum form. Got it?
Yes, sir.
Yes or
Yes.
right? So
Yes,
like
sir.
this, you can convert a given expression into
Sir.
sum of product to product of sum and product of sum to sum of product. Now, if you want to convert this given this whatever expression we found, okay. Now, if you want to convert this expression into product of sum, what you will sum of product, what you will do, you will again take the double complement of this f. Now this is f, okay, new f. So you have to take the double complement of this, and double complement of this is nothing but whatever. Now three different combinations came here, remaining are 5. So 5 different combinations whatever remaining, okay, this out of this whatever 5 combinations are remaining, that you have to write down over here like this. Okay, you have to write down, and then you have to apply the De Morgan's theorem, and that will give you the sum of product. Got it?
Yes, sir.
Yes, sir.
Okay, fine. So you can take such type of examples from the question paper, and you have to try it at home. So we'll stop over here, and then next lecture. Okay, we'll take this one question. Okay, we'll stop over here. In next lecture, we'll take this canonical SOP from the truth table and canonical POS. We have still 5 minutes, right? So we'll cover this, then that will be the end of this. So you have to solve it at home. how much practice you do at home, it depends on your efficiency. Means it will result in your efficiency, because if you solve more number of problems, that will give you idea how to solve the problems, and that will be easy for you in exam. Okay, so
Yes, sir.
okay, next point is canonical SOP from the truth table. So what you have to do, you have to consider rows width of truth table for which the output is 1. You have to consider only those rows which are having output 1, and then in those rows, what you have to do, you have to see the input variables. If it is having 0, you have to mention it bar. If it is having input variable 1, you have to mention it 0. I mean, it's not uncomplemented form. Let's see how to do. Let us say this is a example of adder. Okay, full adder. So if I'm adding it, what I will get, 0 plus 0 plus 0 is 0, right? And there will
0.
be no carry. There will be no carry. 0 plus 0 plus 1 is 1, and there will be no carry.
1.
No carry.
0 plus 1 plus 0 is 1, and again no carry. 0 plus 1 plus 1 is 0, and carry will be there.
0. 1.
1.
1.
1 plus 0 is 1, and there will be
No carry.
no carry.
No carry.
1 plus 0 plus 1 is 0, and there will be a
Carry.
0.
Carry
carry
1.
1.
carry 1, right? Then 1 plus 0 is again 0, and there will be
No carry.
carry.
1.
1 plus 1 is 1, and there will be carry.
1 1. No carry. सर कैरी होगा
Right.
हाँ
हाँ कैरी रहेगा क्योंकि 1 plus 1 is 0 plus 1 is okay 1 plus 1 is 0, so carry will be 1, and 0 plus 1 is 1, so that's the 1. Got it?
yes sir
This is
Yes.
the adder.
Yes, sir.
Now if I want to find out SOP for sum, okay, for sum, if I want to find out SOP, what I have to do, I have to consider those rows which are having sum is equal to 1. Only these 4 rows I have to consider. Remaining I will not consider. So these 4, this one, then this one, next is this one, and this one. Only these 4 rows I have to consider, and I have to write down the equation. So since A is 0, so what I will write down, A bar, right? B is 0, so B bar. C is 1, so C plus. Next row, A is 0, so A bar. B is 1, so B, and C is 0, so C bar. But it plus. For this, A is 1, so A. B is 0, so B bar. C is 0, so C bar. Plus, for this, A is equals to 1, B is equals to 1, C is equals to 1. So A, B, C. All of you got this? Yes or no?
Yes, sir.
yes sir
Yes,
So
sir.
sum is equals to A bar dot B bar dot C plus A bar dot B dot C bar plus A dot B bar dot C bar plus A, B, C. This is the SOP form of sum. Got it?
yes sir
Yes, sir.
Okay.
Yes, sir.
Similarly, we can find out the SOP form for Cout. We can find out SOP form of Cout also. What we have to do? We have to find out the rows which are having Cout is equals to 1. Got it? And then you have to look at the input side. So here A is 0, B is 1, C is 1. So what you will write? A bar, B, C. Next, what we will write down?
A
A
B bar C.
B bar C,
B bar C.
A B bar C
C.
plus
Plus
C,
A B C bar.
A
A, B, C bar.
C bar
C bar.
plus
Plus A
A, B, C plus A, B,
A
C.
B C.
C.
Got it? So like this, we
Yes,
can
sir.
write down, means with the help of truth table, we can write down the SOP form of sum and CO. In the same fashion, if you want to write down its POS form from the truth table, how to do it? So this is SOP. This is SOP, sum of product. Now if I want POS, how to do it? Here itself I am telling you. Just look at, if I want to find out for sum, how to do it. You have to do the inverse of that. What you did, you gone to the rows which has value 1. Now you have to go to the
Yes.
rows which are having value equal to 0. Okay, so we need to consider these rows: 0, 0, 0 and 0. Got it? And if A is 0, you have to consider uncomplemented, and if A is equals to 1, you have to consider complemented. So how we will write down? A plus, now it is POS, product of sum, so that's why A plus B plus C into, second is this. Okay, so A is 0, that's why A plus next is B is 1, that's why B bar. C is 1, that's why C bar. So B bar plus C bar. Got this? Again, here A is 1, so A bar plus B is 0, so B
B
plus
C bar.
C bar.
C bar.
Here A is 1,
Yes, sir.
B is 1, C is 0, so
A bar plus B bar
plus
plus
B bar plus
C.
So this is sum in POS form, that is product of sum form. Whereas in sum of product form, it is like this. So just you have to take inverse of sum of product in POS. So if you observe, this is the okay, now look, we have taken the complemented form of 1, that is 0. Here also we have taken the complemented form of whatever we took previously. That's why in this expression, if you observe, we have taken remaining terms which are not there here in this, right? Here also, if you observe, we have taken those terms which are not considered previously. So POS is nothing but the complemented form of sum of product, and sum of product is the complemented form of POS. All of you got this?
Yes, sir.
Yes.
So this is like this.
Yes.
Similarly, we can go for CO out. So CO out, we have to consider this, 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 and this, and we can write down its expression for POS. Got it?
Yes,
Yes,
sir.
Any
sir.
doubt? This?
No, sir.
Okay, fine. So we'll stop over here. This is the end of today's lecture.
Yes, sir.
If you so what I expect that you should try it at home, and if you face any difficulty, you can ask me. Okay, so I hope any question,
No, sir.
okay, fine, then we'll stop over here. We'll stop over here, and we'll see the remaining things in next lecture. Regarding practical, I have already uploaded the video as well as PDF of lab manual. So just go through it and perform it. Otherwise, we'll take one lecture. But I expect that you should do it. Otherwise, I will take a lecture and I'll show you how to do it for remaining practicals. Okay?
Yes, sir.
Fine. Thank you all. You can leave the
Thank you,
session
sir.
now.